Hi, welcome to this video where we will review some of the new features of CENOS Radio Frequency. The case we will be working with today is a printed Yagi antenna for use on a CubeSat satellite. The first thing we have to do is to select the working approach. I will select from CAD. Then I will upload our geometry into the software. The application will ask you how you want the airbox creation to be done. Since I want the software to do it automatically, I will select yes. After that, just press continue. This time we are going to set up our geometry from scratch, so I will select the custom application in order not to have predefined roles. So let's delete this port. Now we are going to start assigning the substrate, which is this one. Then we are going to continue with the patch, changing to the faces tab. So I just need to select these faces and assign patch. The next object is going to be a conductor, so I change to volumes. Then I will add a dielectric, and then we have another conductor. Finally, we have another conductor for this structure. So in this case, the CubeSat structure is simulated using a simple cube, but remember that you can also work with more detailed models. The last thing we need to do is assign a port, which is a coaxial, so we need to assign this phase. And we are ready to go to the physics section. We are going to run a frequency sweep, so I'm going to define the starting frequency. Then we have the end frequency and finally the frequency step. Now we are going to assign the materials. So for the substrate, I have defined this material, which has these properties. Then we will continue with the conductors. So we have this conductor set as a perfect electric conductors. So for the structure, I will change the material to aluminum. For the dielectric, we will select Teflon. Then we have the coaxial port. As you can see here, we can input the impedance with resistance and reactance. In this case, I'm only interested in the real part, so I will leave it as a 50 ohms. For the patch is set as a perfect electric conductor, and that is it. We need to click on run, then save the case, and finally the computation will start. When the simulation has finished, this window will be displayed where you will be able to observe different data such as the magnitude and the phase of the S parameters, also the impedance, the values of the VSWR, and so on. So you only need to change between these tabs and you will be able to see the results. For the radiation pattern, you are able to see the polar plots. You only need to change the plane that you would like to see. And also you will be able to see how it changes depending on the frequency selected. In this section, we also have the custom plots tab. When you click on this button, you will see two things. The first one is that two plots corresponding to a sine signal, and the power difference plot of the simulated model will be automatically displayed. On the other hand, you will notice that an editor will open with the code corresponding to these plots, where you can modify the data and create new graphs. So we have here all this information, and let's say that I would like to change the value of this graph. Let's change this value, save the code, and you only need to click on reload the information, and as you can see here, it's automatically updated. As I mentioned earlier, you can add and customize the graphs. For example, in this case, I took the VSWR values provided by CENOS Radio Frequency to create a new graph. So as you can see here, we have the previous plot and the new one. If you would like to see the code for these plots, you only need to click on this button and all the information will be displayed, and you will be able to see the changes and add modifications. And last but not least, don't forget that with CENOS Radio Frequency you can see even more information. When the simulation is finished, a preview window will also be displayed, where you will observe the 3D radiation pattern as well as the electric field distribution on the antenna. You can change between the frequencies and observe how the behavior of the antenna changes depending on the objects around it and the frequency you are working on. So that's all for today. Thanks for watching.